Assalamu alaikum everyone. Today we are going to discuss about pulse laser deposition technique. This is the outline of today's presentation. First of all, we will discuss about thin film deposition, then we will discuss about the pulse laser deposition definition and its experimental setup with advantages and disadvantages of PLD process, and at the end we will discuss about the basic theory of PLD. So let's start. This is the setup for thin film deposition technique. If any kind of method through which you can deposit thin film deposition, the basic process is that you evaporate the precursor material by any physical way. You can heat them, you can evaporate them, you can sputter them, and move these atoms from this position to the substrate material, and when they reaches on the substrate, they will diffuse on the surface of the substrate material, and at the end they will deposit a thin film. However, the after reaching on the surface of this substrate material, the atom of the precursor will diffuses according to this equation. D is equal to d naught exponent minus epsilon d over kT. This epsilon d is the activation energy for diffusion, and for the most cases it is about 2 to 3 electron volt. However, the kT is the energy of the atomic species, and when the atom is reached on the surface of the substrate material, they will move according to their this activation energy. If they have the enough amount of energy, they can diffuse on the surface of this substrate until they minimize their energy, and they will stabilize on a particular location or particular point, and they will get a stable position. Moving on, there are a number of techniques exist through which you can deposit thin film, and the most common are evaporation, molecular beam epitaxy, MBE technique, chemical vapor deposition, and sputtering. In MBE technique, basically what you do is you evaporate the target material by any method, and these evaporated particle will deposit on the substrate material, and a thin film is deposited on the substrate surface. However, in any kind of chemical vapor deposition technique, there is a chemical reaction involved. That's why this is CVD, or chemical vapor deposition, and all the reactant precursor are in a gaseous stage, and they will react with one another on the surface of the substrate, and will deposit a thin film on the substrate surface. In the sputtering, it is the most established technique to deposit thin film. What you do is you bombard the target material with argon ions, and these target material will sputter out from the surface of the target material and will move toward the substrate material and deposit on the surface of substrate and form a thin film. So these three techniques are most common and well studied. However, the PLD is a new technique, and today we are going to discuss about this pulse laser deposition technique. This is the experimental setup. Here we have a target material. Target material is the material which you want to deposit on the substrate material, and in the very opposite to this target material, we have a substrate material, and a laser beam, which is the energy source of energy in this process, is fall on the target material. Here, the point where the laser beam is fall, a plasma is generated, and that plasma basically evaporate the target material, and those evaporated atom will move toward the substrate material and deposit on the surface of the substrate and form a thin film. Moving on, one very important point, that this whole procedure is done in the ultra high vacuum in most cases. However, if you want to establish any kind of reactive environment, you can also introduce oxygen or nitrogen for the deposition of oxide or nitride thin films of this target material. And this target material is mostly made up of metals or semiconductors, and because these kind of thin film is deposited for most electronic circuit or electronic devices, and metals or semiconductors, you know that they are excellent conductor of electricity. Similarly, the heating source is laser beam, and it is about 10 nanosecond pulses, and the procedure is being done in atmosphere to ultra high vacuum. if you want to deposit oxide film, you can use atmospheric environment. However, if you want to deposit some particular metallic layer with highest purity, you have to create and maintain an ultra high vacuum. Moving on, this is the experimental setup. Practically how this procedure is being done. Here you can see the plasma is generated by due to the falling of the laser beam. Here we will discuss about the advantages of PLD. PLD is a very flexible technique, easy to implement, and one important feature of this is the growth could be carried out in any kind of environment, and variable growth rate you can control it has variable growth rate because it has multiple parameters through which you can control the growth rate. Similarly, exact transfer of complicated material can be also deposited through PLD technique. Epitaxial growth can be also accomplished at low temperature, and resonant interaction is possible because them arrive in bunches, allowing for much more controlled deposition. Because you know that in PLD process, plasma is generated and the evaporated species is an atom of that target material, and that's why you can control the process by varying the intensity of the laser beam, by changing the distance between the substrate and the target material, and similarly greater control of growth by varying laser parameters. By changing the laser parameter, you can control the heating rate and evaporation rate. As a result, you can control the growth rate on the surface of the substrate. However, there are few disadvantages of PLD process, as it is the target material is exactly opposite to the substrate material, and that's why we can estimate that the surface that is exactly opposite to plasmonic region will be covered with higher number of atoms as compared to the away from that point. That's why the uneven coverage of the thin film is accomplished through this process, which is not desirable in most cases. And similarly, higher defect or particulate concentration is possible through this process, and not well suited for large scale film growth. And this is the main big disadvantages of PLD process, because in most processes and most commercial techniques we want a large scale production, and if we have a thin film, if we want to deposit a thin film comparatively large area, then PLD is not a suitable technique, because for large scale you have to create, first of all you have to create a large chamber so that you can create you can place your sample. Similarly, creating ultra high vacuum in such a large region is really impossible, and if you create it, it is most expensive technique. It would be, of course, the most expensive technique. Similarly, mechanism and dependence on this PLD is still not optimized fully, because it is under study, under research. That's why we can say that this is the one more disadvantage of this technique. In the coming lecture, we will discuss about the mechanism of this PLD process and how the things